Okay. So this one, taking out the GCF or taking out greatest common factors. So remember, when we say the greatest common factor, guys, when we say the greatest common factor, it's what they have in most in common. So in between both of these, they have a 3 in common. So I take that out and divide 3 out of both of these things. 6 divided by 3 is 2, so 2x. And 15 divided by 3 is 5. So your answer in a multiple choice test will look like 3, parentheses, 2x plus 5. Next one, 12x squared minus 14x. I'm going to take out what's in common. The best thing I could take out is a 2 and an x, which means I'm going to divide both of these by 2x.
So 3x.
So 12 divided by 2, which is 6x, and 14 divided by 2, which is 7. Next one, I look at each part individually. First, I look at the numbers, 10 and 15, they have a 5 in common. Then I look at x third and x second is x to the second because they have 2 x's in common. And in y and y squared, they only have a single y in common. So I'm going to divide both of these by 5x squared y, 5x squared y. So it's going to be 10 divided by 5 is 2. X cubed divided by x squared is x. Y divided by y is nothing. Plus 15 divided by 5 is 3. X squared divided by x squared completely disappears. Y squared divided by y means there's a y left over here. Next one. In this situation, we're taking out what's in common. What's best in common here is a 4. So I'm going to take out a 4, and I take it out each individual one. So it's 4x squared plus 2x minus, 3x squared minus 2x plus 4, minus 4. That's my full there. And you look one more time, there's nothing else I could take out, so there's nothing else I take out. Next one. Yes.
Are you going to be here on the study days?
Yes. Which is only tomorrow. I guess, but your finals already passed, so. So, you don't have to be here for the study day. You're not, what is it? It's not mandatory, yes. It's not mandatory to come to school.
Like, there's no classes. It's not like period 1, 2.
No, you just show up, and if you want to find your math teacher, aka me, I'll be in 320. All right, x squared plus 6x plus 9. I need factors of c. So things that multiply to c that add to b. So things that multiply to 9 that add to 6, that's 3 and 3. That adds up to 6. Now, here's the important part. In the multiple choice, you're not going to see it like this. This is not how the answer is going to look like. Because they're exactly the same, I can rewrite it as x plus 3 to the second power. Once again, because they're the same, I can write it x plus 3 to the second power. So your multiple choice answer for this type of question would look like that on the bottom. As a reminder, if you're multiplying something like x plus 3 squared, you have to first rewrite it as x plus 3, then FOIL. X squared plus 3x plus 3x plus 9, x squared plus 6x plus 9. This is not part of... What's up?
This is not in the test packet.
Yeah, it is. This is literally the test packet. Yeah, we did it, but the recording messed up, so I got to record it again.
With the right side is multiplication.
This one would be called factoring, while this would be called simplifying or multiplying.
It's not what we're doing, right?
But this is the same packet as from before. You still have the packet?
I wasn't here.
Okay, here.
That's foiling though. It's foiling.
This is foiling, but foiling is simplifying.
Like number 5 on the left side, like the
instructions will say...
So 9 is at times, right? And then the 6 is the plus, right?
Yes, but the 5 is factoring. It's the official instructions. Yeah.
I have a question. Are you going to label what everything is? Like, are you going to write permutation?
No. It would just say factor blank. Factor blank. Factor blank.
And do we have to know all the bias methods, like bias question?
How the question's set up in multiple choice, your options will be there. So you don't need to know the names. Like, you just choose which one you want. Or which one's correct.
But, like, do I have to know, like, what a bias
There is a-
question is? Or is it going to be like this?
No, there's going to be a question like, here's a question. Why is this bias? And then you pick option one.
Wait, I don't understand.
Okay.
Like you're supposed to write this is bias and then the
No. Since it's a multiple choice test, I'm going to give you a question. Would you like delicious pizza or disgusting salad, right? And then and the multiple choice. Yeah. So one of the options will say something like, they're using words like delicious and disgusting.
and then
Delicious
Yeah.
and disgusting.
Yeah. It's not biased because he says pizza first. It's not biased because.
Wait, hold up. What happens if someone finds the delicious pizza disgusting?
Well, no. But the question is implying it's already disgusting.
For this, it doesn't matter, like, which of the way we do it, right?
What do you mean? Yeah, it doesn't matter. You can choose either way. All right, this one, x squared plus 10x minus 24. We're going to do things that multiply to negative 24 that add to 10. After a couple of things searching, you should figure out that's going to be 12 and negative 2. Reminder, this is negative 24. So 6 and 4 does also add up to 10, but that multiplies to positive 24. So that's not my answer. It's going to be 12 and negative 2. So x plus 12, x minus 2. Make sure you know, if you had this question on the test, I would put the fake answer. One of my fake answers would be x plus 6, x plus 4. It's multiple choice, so 3 fake answers.
Mr. Double,
Yes.
I have a question.
Yes.
So how about if I just did, how about if we get like 63 out of 70 correct? How much would that be?
You can do the math.
Is it 60 but it's actually like 60 divided by 70?
Yes.
Oh.
So this one, I want to multiply to negative 10. So I have to multiply, I need to multiply to negative 7. So I need to do negative 5 and negative 2. Because 5 and 2, while it multiplies to 10, adds up to positive 7. So I need to do the negatives. So x minus 5, x minus 2. Next one, divide or factoring when you have a number in front, like this one, 3. And because of that, we're going to take this 3 and bring it over to the 8. So we're going to do slide and divide. We're borrowing the 3, so we're going to have to pay it back later. So x squared plus 14x plus 8 times 3, 24. Then I find things that multiply to 24 that add to 14. That's like 12 and 2. So I'm going to rewrite this as x plus 12, x plus 2. In this case, I borrowed the 3, so I'm going to have to pay back the 3. So I'm going to divide by 3 on both sides. Now on the left side, it's x plus 12 over 3. We could simplify that to x plus 4. So that's useful. But this one cannot be simplified. Whenever you can't simplify, the bank takes it back. So we have to give it back over here. So it's going to be 3x plus 2.
I have a question.
About that graphic?
What?
About the thing you showed me, like the graphic?
Yeah.
Where the crisscross is the answer.
No,
Oh.
it's not that.
Give me a sec. Let me do this one. So let's take the 4 and lend it to the negative 6. So it becomes x squared plus 5x minus 24. You notice I like 24 just because they have a lot of factors. So I need things that multiply to negative 24 that add a 5. You'll do a little searching and end up being 8 and negative 3. So x plus 8, x minus 3. Then we're going to divide 4 on both sides because that's what I borrowed. The left side is good, but the right side I need to give back. So it's going to be x plus 2 and 4x minus 3. Oh, that's not what I want. I'm not sure where my black video finished, so I'm just going to do the next chapter, and then hopefully I don't have any gaps. Okay? Next one, the quadratic stuff. So here we have this one. We need to find the axis of symmetry. Remember, whenever you find the axis of symmetry, is negative b over 2a. In this case, my a value is 1. My b value doesn't exist, so it's 0. And my c value is negative 2. So my axis of symmetry is negative 0 over 2 times 1. Overall, it becomes 0. So my axis of symmetry is 0. But because my axis of symmetry is 0, that also makes my vertex, or the x-axis of my vertex, 0. Just want to make sure this is recorded. So if that's so, we're going to take that and take this 0 and plug it into the equation. So 0 squared minus 2 equals negative 2. So my vertex is 0, comma, negative 2. My y-intercept is, if you remember, simple or always the c value. All right, it's always the c value. So c value is negative 2. This is negative 2. Yes. As the axis. Yeah, so then it becomes y. Yeah, it should be, I guess negative 2 should be over here, but yeah. Next one. Next one. A is 1, B is 4, C is negative 3. So we still use our formula, negative b over 2a. So negative 4 over 2 times 1. That's negative 4 over 2, or negative 2. So my axis of symmetry is here, negative 2, which means the x of my vertex is negative 2. And I take that and plug it into my original equation. So it's going to be negative 2 squared plus 4 times negative 2 minus 3. Negative 2 squared is positive 4 minus 8 minus 3. This is going to be negative 4 minus 3, or negative 7. So it's negative 2, comma, negative 7. Remember, our y-intercept is always the c value. So that's just going to be negative 3. Next one. Be careful here. Our a value is negative 1 because there's a negative in front of it. Our b value is 4, and our c value is negative 2. So in this case, it's going to be negative 4 over 2 times negative 1. That's negative 4 over negative 2, which results in positive 2. So our axis of symmetry is positive 2. That gives me the x of the vertex, and I plug it back in. Remember, the negative is outside the x. So it's negative 2 squared, just like this, plus 4 times 2 minus 2. So this is negative 4 plus 8 minus 2. That happens to also be a positive 2. The fact that the numbers are the same is just a coincidence. So this is 2. And your y-intercept, your c value, is negative 2. Next one, graphing quadratics. So this one, y equals x squared minus 2x plus 3. So we still follow the same process. A is 1, b is negative 2, c is positive 3. So in this case, it is negative 2, or negative b, over 2a, which is 1. So it's 2 over 2, or 1. So my axis of symmetry is 1, which means my vertex is 1, comma, I don't know yet, I'm going to plug it in. So 1 squared minus 2 times 1 plus 3. So 1 minus 2 plus 3. That's negative 1 plus 3. That's going to be 2. So my vertex is 1, comma 2. As a reminder, always put your vertex in the middle of the table. So 1, comma 2 right here. And I'm always going to go 2 smaller, so 0, negative 1, and 2 bigger, 2 and 3. With that in mind, what I could do is use my calculator to my advantage. I'm going to click y equals, and I'm going to plug it in the equation as I see it. Follow my mouse to figure out the buttons. X squared minus 2x plus 3. If I graph it, I get the U shape, which is useful. But what I really want to see is the table. Because if I go to the table over here, let me make it bigger. If I go to the table over here, 1, comma 2 is one of my answers, which means then I could plug in the rest of the answers. 3 and 3, 6 and 6. You could always do this by hand also, by plugging in 0 or 2 and plugging in 3 or negative 1. You know you did it correctly because it should be a mirror or symmetrical on both sides. Now I'm going to graph this, so 1, comma positive 2, 0, 3, and 2, 3, and 3, 6, and negative 1, 6. So I graph my points. And what's important to notice here is when I say solutions, that's when it hits the x-axis. In this case, this does not hit the x-axis, so there's no solution. Next one, same process. A is 1, B is negative 2, C is 1. So I'm going to do negative 2, or negative 2, over 2 times 1. That's 2 over 2, or just 1. Axis of symmetry 1, vertex 1, comma blank. 1 squared minus 2 times 1 plus 1. 1 minus 2 plus 1 equals 0. So this is 0. So 1, 0. 2 smaller, 0, negative 1. 2 bigger, 2 and 3. In this case, you can use the calculator to plug it in. I'm just going to do it quickly to save time. 1 and 1, 3, 4 and 4. Now you're going to graph your thing. 1, comma 0, 0, comma 1, 2, comma 1, 3, comma 4, negative 1, comma 4. And in this case, there's only one place where it hits the x-axis, which happens to be 1, comma 0. So your solution is 1, comma 0. This happens to be the same as a vertex. It's not always going to be the same as a vertex. If you have multiple points, you will list multiple points, okay? Oh, we did this. Let me just clear it so I can do it one more time. All right, for this one, how many solutions this parabola has? Since it hits the curve none, it'll be no solutions. Or 0 solutions, I guess I should say. If it hits the curve exactly once, like over here, that's 1 solution. And if it hits the x-axis twice, like over here, that'd be 2 solutions. So looking at the graph, you could tell if it's 0 solutions, 1 solution, 2 solution. So in this scenario, you could either, because you have a multiple choice test, what you could is use the discriminant formula. So this is the discriminant formula. So A equals 3, B equals 4, C equals 5. So 4 squared minus 4 times 3 times 5. 16 minus 15 times 4 is 60. Negative 44. Negative 44 is a negative number. Negative numbers means there's 0 solutions. This one I might have not right because there's two ways to do it. So you could get that where 0 solutions, or because you have your calculator, you could go to your calculator and put in the formula 3x squared plus 4x plus 5 and graph. And if you see the graph, how many solutions does it have? 0. So you could graph it also to get the answer.
I have a question. Is the answer gonna be like the 0 solution?
So the 4 multiple choice is going to be 0 solution, 1 solution, 2 solution, and I'm probably going to put negative 44 solution to trick people who thinks that's the answer.
Wait, so what's one solution?
1 solution be equal to 0.
2 solutions is
Positive.
1/5 and 2 solutions.
Yes. And go ahead.
On the calculator,
Yeah, you click the graph. Y equals to get to plug it in, and graph to get the picture. And it's on the top row, okay? All right, next one. Same thing. 7 squared minus 4 times 4 minus 2. So 49 plus, this is 16, 32. This is 81. I really don't care what the exact number is. All I care that it's positive. So because it's positive, this one's 2 solutions. And then this one, 6 squared minus 4 times 1 times 9. 36 minus 36 equals 0. Because it equals exactly 0, that's 1 solution. And again, you could type this in your graph and you'll see the picture. You could hit it how many times it hit the x-axis. I believe that's everything on the second video that I missed. So I'm going to close the video out and stop recording.